everyone. In this video, we are going to write absolute value function or equation given a word problem or a graph. Let's have a review on absolute value function first. In the picture, you will see the shape of the parent graph of an absolute value function, its parent equation, and the equation in graphing form. We will use this information in the problems that we're going to have here. So let's take this first problem right here. What is the equation of an absolute value function that has a vertex at -4, -5, and passes through point 2, -4? We're going to be using steps in order that we can solve for this kind of problem. The first step is to determine the locator point, and we label this as HK. And we label the other point as xy, and then we plug these values into the equation in graphing form to solve for a. So in this problem that we have here, we label the vertex, or the otherwise called the locator point, as the hk, and then this other point right here will be our xy. So we move on to the first step right here. We plug this into the graphing form of an absolute value function, which is y equals a absolute value of x minus h plus k. So we are going to plug the values in. So we start with y, which is -4. So I'm going to write -4 is equal to a is missing. Then we have the x value of 2. Then that's going to be minus our h is -4. So I'm going to write -4. That's absolute value. Our k is -5. So that's going to be -5. Now notice that these two minuses that we have here is not randomly written in here, but instead this minus comes for this first minus comes from the subtraction right here, and this other minus here comes from -4. So then we can go ahead and change this to plus and plus so that we can simplify it. This would come out -4 equals a. That's going to be 2 plus 4 would be 6. So that's the absolute value of 6 minus 5. So the absolute value of 6 is just 6. So we can go ahead and rewrite this as 6a minus 5. Now we want to solve for a. So then we're going to add 5 to both sides. We're going to add 5 here. So then we can cross the 5 out. And then we're left with 6a is equal to +1. So then we go ahead and divide both sides by 6 so that we can solve for a. So then we have here, cross this 6 out. So our a value is 1/6. So this is our a value. Now we're ready to move on to the second step. So the second step is to write the equation by plugging in a, h, and k only into the equation in graphing form. So I'm just going to label this as step 2. So I'm just going to rewrite this. That is y equals a absolute value of x minus h plus k. And so the only ones that we plug in are the values of a, h, and k. So then we go ahead and write y is equal to the a value that we solved here is 1/6, and that is the absolute value of x is a variable. We keep it, but we need to change the h. Our h here, so that's x minus, and our h here is -4. So I'm just going to write -4 right there, minus -4. So then we go ahead and subtract the k, which is -5. So then again, we remember that two negatives will change this to positive and positive. So then we are left with y is equal to 1/6 absolute value of x plus 4 minus 5. And this is the equation that would fit to this word problem that we have here. So that means that the vertex of this equation right here is -4, -5, and then it passes through this point to -4. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So this is pretty much similar to the first example that we have, except that in the first example, it's word problem. This time around, we are given a setup of the graph for an absolute value function, but it's pretty much the same thing. So we are given the vertex and we're given the point. So we can move on to the first step. So in the first step, we're supposed to determine the locator point and label this as hk, and we label the other point as x, y, and we plug these values into the equation in graphing form to solve for a. So in this problem that we have here, this is our vertex, so we can label this as hk, and this is our point xy. So then we go ahead and plug it into the graphing form of an absolute value function, which is y equals a absolute value of x minus h plus k. So then we go ahead and plug it in. Our y is negative 3. And then we're missing the a. And then our x is positive 3 minus our h is negative 4. So that's a negative 4. And then our k is negative 6. So again, please remember that this, I did not randomly write this minus and minus here. This first minus is from the operation right here, x minus. So that's 3 minus. The other negative right here is from the value of h, which is negative 4. So I'm going to change this to plus and plus. So this becomes negative 3 equals a. Absolute value of 3 plus 4 is 7. And then that's a minus 6. So absolute value of 7 is just 7. So that would be negative 3 equals 7a minus 6. So then we want to solve for a. So we're adding 6 from both sides. Add 6 and plus 6. So then we can go ahead and cross the 6 out. We're left with negative 3 plus 6 is a positive 3 equals 7a. So then we divide both sides by 7 to solve for a. So then we go ahead and cross this out. Our a value is 3 over 7. Okay, now we're ready to move on to the second step. So the second step is to write the equation by plugging in a, h, and k only into the equation in graphing form. So I'm just going to rewrite that. That would be y equals a absolute value of x minus h plus k. Again, the parameters should be replaced with values. The parameters are a, h, and k. Then we keep the variables x and y. So then we can go ahead and write y is equal to our a is 3 over 7, and then that's the absolute value of x. Our h is, again, it's negative 4, so that's a minus negative 4. And then our k is negative 6, so that's a minus 6. Again, remember, this one can be changed into plus and plus. So then we can go ahead and rewrite the final equation as y equals 3 over 7, absolute value of x plus 4. And then that is a minus 6. So this is the equation for this graph right here. Now, if you want to change this to function notation, you can just go ahead and change this y into f of x. So we can rewrite this as f of x equals 3 over 7, absolute value of x plus 4 minus 6. So pretty much just change this y into f of x if you want it in function notation. Did you get the same answer as this? Good. Perfect. Let's move on to the next problem right here. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. It's pretty much the same thing as the second example, but the only difference here is that we don't have a labeled vertex and point. But we can do that by tracing the points in the graph to determine which one is the vertex and which one is the point. So then from here, we can go ahead and trace this as our vertex. So this is the vertex right here. And then this coordinate is gonna be 3, 4. So I'm just gonna label this as 3, 4. And then we trace the graph to look for that coordinate, which is a whole number. Just a reminder that a line or a graph is made up of infinite number of dots, but it would be easy for us to solve the problem if we have a coordinate in whole number. So then we go ahead and look for that coordinate, and we can see that this if we trace this, we can see that this is the point that we can use in order that we can determine the equation for this absolute value function. So you can actually have more points when we trace it, but we only need 1 point. So this point that we have here is 4, 2. So I can label this as 4, 2. Again, you can use the one across, which is 2 and 2. You can use this one as well. There's like infinite number of points right here, but we only need 1 point and the vertex in order that we can write the equation of this graph. So then from here, we can go ahead and label this as our h, okay? And this is our xy. So we're ready to move on to the first step, which is to determine the locator point and label this as hk and the other point as xy. And then we plug these values into the equation in graphing form and solve for a. So I'm just gonna label this as step 1. Again, the graphing form for an absolute value function is y equals a absolute value of x minus h plus k. So we plug in the values of y, which is 2 equals, a is missing, that's absolute value of x is 4, and then that's a 4 minus our h is 3. So then our k value is 4, so then we can add 4 here at the end. So then we can go ahead and simplify this. This would be 2 equals a, absolute value of 4 minus 3 is 1 plus 4. Absolute value of 1 is just 1, so we can go ahead and rewrite this as 2 equals 1a plus 4, which we don't have to write the 1, so we can go ahead and rewrite this as 2 equals a plus 4. So then we are going to subtract 4 from both sides so that we can solve for a. So then this would come out, we can cross this out. This would be negative 2 is equal to a. So pretty much our a is negative 2. And then from here, we move on to step 2. So step 2 is to write the equation by plugging in a, h, and k only into the equation in graphing form. So we're going to rewrite that. So that would be y equals a absolute value of x minus h plus k. Again, for this step, we're supposed to change the values of the parameter a, h, and k, and we're keeping the variables x and y in order that we can come up with an equation. So in this problem that we have here, or in this equation that we have there, so that would be y equals our a is negative 2. That's the absolute value of x. Our h is 3, so that's a minus 3. And then our k is 4, so that's a plus 4. So this is the equation of this graph right here. So the vertex is 3, 4, and then it passes through point 42. Did you get the same answer as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!